Welcome back, and I so hope you've enjoyed working through the different topics on this Introduction to Natural Language Processing course. Of course, the field of NLP is huge, and there's always new things evolving and new things being developed. In this last chapter of the course, we'll be discussing deep learning, its applications, and where we think NLP might be going in the next decade. Before we start discussing how deep learning has impacted the field of NLP, let's first clarify what we mean by deep learning. This is just going to be a high-level introduction. We're not going to do any code, but if you are interested in creating your own deep learning models, there's a great course on the 365 data platform that I would definitely recommend. So let's get started. Unlike traditional machine learning algorithms, deep learning, also known as neural networks, are built to simulate the human brain and its structure and function. These neural networks consist of interconnected layers that aim to analyze data and uncover patterns. Neural networks consist of input layers, hidden layers, and output layers. Each layer receives its input, applies an activation function, and then passes it on to the next layer. Each layer consists of individual neurons, and the strength of the connections between these neurons, known as weights, determines the impact of these neurons on the final prediction. By adjusting the weights between these neurons through our model training, neural networks can learn from data and use this to improve their performance. There are several different types of deep learning architectures, each suited for different types of tasks and data. For example, convolutional neural networks excel at image and video processing by exploiting spatial correlations. On the other hand, recurrent neural networks use connections that can process feedback loops, so these excel at processing sequential data such as language for NLP. Training a deep learning model involves optimizing these individual weights of the neurons to eventually minimize the difference between the predicted output that our algorithms are giving us and the actual output that we're looking for. Deep learning has made remarkable strides over the past few years and really pushes the boundaries of what we thought would be possible. With the advancements of hardware capabilities, deep learning has become much more complex, able to handle massive amounts of data. It's a super interesting field and especially has amazing implications for natural language processing. So in our next lesson, we're going to be discussing how this relates to NLP and the advancements that have been made in deep learning with NLP over the last few years. So now you have at least a basic understanding of deep learning, let's discuss some of its applications for NLP. One of the most famous examples at the moment, and maybe the reason that you reached out to look for this course, is ChatGPT, an advanced language model built by OpenAI. At its very core, ChatGPT uses a neural network architecture called a transformer. And if you think back to our lesson on sentiment analysis, you'll recall that we used one of these pre-trained transformer models to discover sentiment in our text. More generally, ChatGPT is an example of a large language model. Large language models are designed to understand, process, and create human-like text by learning from a vast amount of data. These large language models are trained on vast amounts of diverse data, from books to websites, articles. Loads of different text data is fed in to allow the understanding of human language, of patterns, semantic relationships, and grammar, so that human-like text can be generated. These models have demonstrated significant advancements in the field of NLP, and have found use cases across the board in chatbots, in content generation, in language translation, so many different applications for these large language models. As we continue to refine and advance these models, the potential for more interactive and more sophisticated advanced human-computer interaction becomes more attainable. So it's a super exciting time to get started in the field of NLP, and I'm so happy that you decided to start your journey with me in this course. As we've been working through the practicals in this course, you may have noticed we often reference the language we want to use. For example, when we were creating our Spacey model, we specified an English language model. And when we're using our stop words, again, we specified we wanted these to be in English. This course has focused on using NLP with English language data, but there are loads of developments being done in other languages that mean NLP solutions can start being used for a global audience. However, it is quite challenging as some languages just don't have the large amounts of easily accessible data required to train these kind of natural language models. Even the way we pre-process text needs to be adapted for each individual language to take into account different grammatical rules and sentence structures and contextual information contained within the written language. So if you're wanting to work with non-English data, what do you do? Well, the first thing I'd recommend is checking out the documentation of the packages we already used and see what kind of languages they support and whether you can just switch out the language models that we used, but continue to use the same code. The other option is to check for additional packages that have been developed with your language in mind. So for example, the INLTK package has been developed for the Indic languages such as Hindi and Tamil. Expanding the language capabilities of NLP is a key aspect of future development to help ensure we create inclusive solutions for a global audience. So, in our next and final lesson, we'll look at some of the advancements of NLP and where we think it might be heading in the future. The field of NLP is expected to continue to evolve rapidly, with technological advancements and the increasing availability of large-scale datasets for training. Here are some ways we can expect NLP to evolve over the next few years. The first is that NLP is expected to gain a deeper contextual understanding, so getting better at understanding semantics and general word knowledge, and even being able to have reasoning capabilities behind its decisions. The second is multimodal understanding, so NLP will be fed not only with text data, but with images, videos, and audio, so that the language model can get an even better understanding of how language works in the different contexts it can be used. As the demand for faster, more interactive NLP solutions increases, we'll also see advancements in the optimization of model architectures, as well as the technologies required to deliver more real-time solutions. We're also going to be hearing more conversations around ethical considerations, biases, and privacy concerns to ensure we keep fairness, inclusivity, and transparency at the forefront of any new NLP development. As you'll have seen going through this course, NLP has so many amazing applications for our everyday lives. I truly hope you've enjoyed going through this course with me, getting an introduction to natural language processing, and hopefully you're ready to start building some NLP solutions of your own.